Hi, today I'm going to be discussing token passing and binary countdown. The previous textbook section covers bitmap protocol, which basically lets every station transmit a frame in a predefined order. Another way to do this is to use token passing. A token, as seen here in this image, is a small message or series of bits that is passed around from station to station and allows each station to send frames if it needs to. If a station has a frame queued for transmission when it receives the token, it can send that frame before it passes the token to the next station. If the station has no queued frame, it simply passes the token on to the next station. Token passing can be accomplished using a couple of different topologies. A network's topology is also known as the shape it forms or how the devices in the network are arranged. As you can see, a token ring topology is when the stations are arranged in a circular pattern, while a token bus is when they're connected using a long line or cable. Efficiency-wise, when using token passing, a station must wait for all stations, including itself, to send the token around, which means the process is slowed if there's more stations. There are also a couple of different token ring protocols that have been used throughout the 80s, 90s, and 2000s. The first is the token ring, standard as IEEE 8025, and it was used as an alternative to classic Ethernet in the 1980s. The second is the Fiber Distributed Data Interface, which was faster than the token ring and used in the 1990s, although it was made obsolete due to advances in switched Ethernet. And the final is the Resilient Packet Ring, which was used in the 2000s. As stated before, token passing doesn't scale well, so instead there's another process called binary countdown that we can use. In binary countdown, each station has a binary address with a set length and broadcasts its address one bit at a time, starting with the highest order bit, from left to right when it wants to transmit. To decide which station gets access to the channel, the addresses of all the broadcast stations are Boolean ORed together, and the highest numbered station gets the channel access. Here we have an example of binary countdown. Say we have the stations 0010, 0100, 1001, and 1010, and they're all trying to access the channel. Each station starts by transmitting its first or most significant bit. The first station would transmit its first bit 0, the second station would transmit its first bit 0, the third station would transmit its first bit 1, and the fourth station would transmit its first bit 1. And all of those bits are ORed together, so we have 0 or 1 or 1, which is 1. Since the resulting bit is 1, the first two stations give up because their first bit doesn't match the result. This process repeats until the station with the highest value remains. As you can see in the image, in the second go-around, we're left with stations 3 and 4, and their second bit is both 0, so 0, 0, 0, so both stations continue to try to compete for the channel. And in the third go-around, the third bit for the third station is 0, while the third bit for the fourth station is 1, and 0, 1 is 1, so the third station quits trying to connect to the channel, so we're only left with the last station, which successfully connects to the channel, and also has the largest value out of the 4 stations. So my question for the class is, which bit is the highest order or most significant bit? And the correct answer is A, because the highest order or most significant bit is always the leftmost bit, while D would be the least significant or lowest order bit, because the least significant bit is always the rightmost bit.